So today we would be solving Leetcode question number 1027 that says longest arithmetic subsequence. So what the question really says is that we need to find that longest arithmetic subsequence or AP which has the largest size among all these. For example, we know what is an AP. We know what is an AP, like for example 1, 2, 4, 6, 8. This is an AP because this is having a common difference. This is also an AP 1, 2, 3, 4, 5. This is also an AP. So we are right now not given with any difference. We are just given with that you need to find that longest arithmetic subsequence with any difference that must be common. Like for here example we have 3, 6, 9 and 12. So I know that if I pick 3, if I pick 6, I pick 9, I pick 12, I get 4 numbers that are in AP and that will be always the longest length. If it says subsequence, we would also have picked 3 and 6 separately, 6 and 9 separately, 9 and 12 separately, 6, 9, 12 separately, 3, 6, 9 separately. Like we here discuss each and every possible sequence. We could also have picked no, there are no more subsequences. Like for example in this we have a longest arithmetic subsequence of 4, 7 and 10. 4, 7 and 10. So we could have picked 4, 7. That gives us the difference of 3. And 7 with the difference of 7 and 10 gives us also a difference of 3. The total length that is 3. So till now we are clear that we need to return that maximum length of AP that can be generated. The maximum length of AP that can be generated with whatsoever difference we want. So how will we go about this question? So first and foremost, I know that I would be at any point of time requiring the size of my array. I would require, so let me just store it in some variable n. Okay. At some point of time, I also know that this is given, and we from our common sense we can guess that if n goes less than equal to 2, in that case we just return n as it is, because for an AP to be there needs to be at least 2 or more numbers. So at least 2 numbers must be there to generate an AP. If there are only 2 numbers or just 1 number, then just return that count only. Okay, so far so good. So we need to return a maximum length. For calculating that maximum length, we would be requiring some comparative variable. So I would take answer 1 as initially 0. Now the main thing, supposingly what I am gonna do is I would be picking this number and this number, ith and I plus 1th. I would be taking their difference. And I would be just iterating from 0 up till I minus 1. I took I, and I took I plus I took I, and I took I plus 1th index numbers. Their difference. So I said let us assume a AP with their difference. So let me check back. So let me check back that is this difference existing. So from here I got a difference of 3. Now I checked for 6 minus 9. I got a difference of 3. I again went more back. I saw 6 minus 3. That also gave me a difference of 3. Then I am exhausted with my indexes. So in this case I return a distance of 4 or a length of 4. So I know that at any point of time int I is equals to 0, I is less than n, and I plus plus. This gives me I. My j would always be a plus 1th of this. Okay, these are my two numbers, I and I plus 1th. For int j is equals to I plus 1 up till j is less than n and j plus plus. That is very much it. I know I would be comparing my answer one variable so that it stores the maximum length. I would be saying answer 1 is equals to max of answer 1 comma something. Now what is that something? That something would be I have received my ith number, I have received my I plus 1th number. Now let me go back and check, are there more numbers with the same difference that I and I plus 1th number are generating. So I would be requiring a function. I would be requiring a function. I would be requiring a function that would result me in returning an integer variable that would require index I am currently at, that is my ith index. So I would say just pass an index. Okay, I also require a difference with which I would be checking back. I would be requiring my vector int ampersand nums, my nums array. So I am sure that I would be calling my answer variable, which would be checking for rest numbers. Are there any more numbers which can be added into our AP? Yes or no? So I would be passing my ith index. I would be passing the difference, that is numset j minus numset I, next number minus previous number, next is j, previous was I, they are difference, I plus 1th number minus ith number, they are difference, and I would be passing my nums array. And there is something more that needs to be added, and that is the plus 2. I plus 2, I would be discussing this after writing my function. So coming to my function answer, what answer really returns is any more number that can be added besides these two numbers. So I would be writing my base case at the last. I would just say for now let us take int res is equals to 0 because it will be calculating the length. So I would say just iterate from int k is equals to index minus 1, the index that I would be passed. So a lesser than that up till k goes greater than equal to 0. Yeah, I was pretty much sure from ith, this was ith, this was I plus 1th. I would be going from I minus 1th up till 0, that is only index minus 1 up till 0, and k minus minus. And then what I would be saying is that if nums at index minus nums at k is equal to the given difference that I have passed, then this number can be added to my DP. Just add this number to my DP and calculate what can be the max length. So just add this number 1 plus and then call for the function again, and the current index now becomes k. The current difference remains the same, and I again go on calling for my nums, and that is pretty much very it. At the end of the function I would just be returning my res. What would be the base case? I am going back. From here I went, these two numbers were there, I went here, I went here. So when I am exhausted with my indexes, if index goes less than 0, then in that case return 0. That is pretty much very it. I think we are good to go as of now. Now if I just return ans1, so ans1 would now contain the maximum length of AP that can be generated from the whole of the array. But we all know that we have not memoized it, so this would result into a TLE. The test cases were passed, but now the main resultant test cases would not be passed. That would give us TLE. So we would try. Yes, we have got TLE, time limit exceeded. So we would now go memoizing our answer, memoizing our function. So what we can really do is just create a map, an unordered map that would take int comma int, whose name we can give as dp, and that would contain indexes including n, so that is by n plus 1. I'll just pass my map in my function. I'll just pass my map, unordered map, int comma int dp. That is pretty much it. I say that after the base condition, if dp at index dot count difference is existing or is greater than 0, then that means we can at that moment return dp at index at difference that count, because dp at index at difference would be storing the length for that difference. Okay, for that difference, that maximum length it would be storing. Just go on and dp at index at difference is equals to res. Just call for the function inside, and I think that is pretty much very it. We are good to go. I think we can just submit it. I think this would accept. Okay, so I think this would not get accepted. This would also result in a TLE. This would give a TLE again. That is, recursion and memoization would not lead us into the correct answer that we are expecting. We need something else. So at this moment we would be solving this question using purely tabulation. So what tabulation really says is that just we can go on creating a tabulation right here. So what I really know is that I would be requiring my map, that is dp. Okay, let me just cancel this all. Now at this moment I say, let me just create an answer variable, and answer is equals to 0. Okay, I have my dp. Now the most important thing, from where till where I would be iterating. I say for, now just hear me carefully, for int I is equals to 1. Okay, for now less than n, go up till I plus plus, go up till n minus 1, and iterate j from int j is equals to 0 up till j is less than I and j plus plus. Okay, what I will really check is int difference is equals to numset I, that was the rightmost value minus nums at j, that will always lie towards left of I. If this was I, j would iterate from 0 up till I minus 1. Okay, if this was I, j would iterate from here till here. I am taking a difference. I would always say include that number. I would always say include that number. And let's just check in our map in our DP that was this count really existing. If DP at j, if I started taking differences, like for example my I was this, sorry, let's take here. If my I was this, I started taking differences from here up till here. So I just said take this, take the difference. I started from here. I started from here, and then from here I went all the way up till I minus 1, and I said, was dp at j really existing? If because dp at j was existing previously, then that would have contained some length, of its previous progression. So if dp at j dot count diff, that is, if this difference was existing previously and we have a value at dp at j, then that would contain a length, of progression that would have started from jth value at num set j, and that has been stored in dp of j at difference, dp at j at that difference. From num set j we would be having some progression that with that difference that we are looking for as of now. So I would just be saying if that difference exists with some count of progression, then say count for now is equal to dp at j for that difference. Okay, and then add this present number I, add diff to my count and at last just calculate answer is equals to max of answer comma dp at I at diff, and that is it. At the end we would just be returning answer, and if this goes all right, I think we would be expecting accepted, and I think this goes right and we are good to go. Okay, so it is accepted guys, and I forgot to explain something in our memoization portion why we added 2 here. We added 2 here because we need to count these two numbers ith and I plus 1th also in our progression. So thank you very much guys for watching this video. Please subscribe and like the video. Thank you, and let's meet in the next video. Bye.